In activity 2.1, we're going to discuss properties of exponents. Take a look at example 1. Say we're going to multiply x cubed times x to the fifth. Well, remember, x cubed really is 3 x's multiplied together, right? That's x times x times x. And x to the fifth really means 5 x's being multiplied together, or x times x times x times x. So x cubed times x to the fifth really is the same as saying x times 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 x 8 times, or x to the 8th. So a simple rule is really saying when we have the same base with different exponents, we simply just add the exponents. So 3 plus 5 is 8. So x cubed times x to the fifth, when we add the exponents, we end up with x to the 8. So let's try a few practice problems. On page, looks like 166, I'd like to try problems, 1 through 10. And I think I'm going to do all of the even problems. The odd problems, the answers are in the back of the book. Okay, so we're going to focus just on the even problems right now. So problem 2, we have y cubed times y cubed. So we can think of that as y times y times y times y times y times y. Right? We have 6 y's, so our answer is going to be y to the 6th. We can also think of this as, using our property, we add the exponents, right? Since we have the same base, which is y, we just add the exponents. So you can see that 3 plus 3 gives me 6, and I'm left with y to the 6th. And that's my final answer. When I look at number 4, it's similar to problem 2. The only difference is instead of y, we now have a base of 4. So we can think of this as 4 squared, or 4 times 4, times 4 times 4 times 4. So I have a total of 5 4s. So this would be 4 raised to the 5th. And again, we could always just use our formula that says when we have the same base, we add the exponents. So our exponents are the 2 and the 3, so we have 4 raised to the 2 plus 3, or 4 raised to the 5th. And if we check our calculator, we can see what 4 raised to the 5th actually, what the value is. So here's my calculator, and I enter 4 raised to the 5. I press enter, and it looks like I have 1,024. So let's try example number 6. So I rewrote number 6 using the associative and commutative properties. Basically, I grouped the 2 and the 3, and I grouped the expressions with the same base, the k's, and I feel like maybe it's a little easier to look at it this way, right? We know 2 times 3 is 6, and we know k squared times k to the 5th is k to the 7th. So we're left with 6k to the 7th. Let's try number 8. So again, I tried to group everything together. The negative 2 and the 3 I grouped together. The x squared and the other x squared I grouped together. The y squared and the y cubed I grouped together. And when we simplify this, and here's my final answer, right? The negative 2 times 3 is negative 6. X squared times x squared is x to the 4th. And y squared times y cubed is y to the 5th. Last one, problem 10. So for number 10, I've grouped, really just the b's are the only thing I could group. And there's my final answer. So that was the first property. That was the property of multiplication. Again, the property of multiplication says when we have the same base and we multiply these expressions, we add the exponents. The next property is the division property. Right? We're given this x to the 5th divided by x cubed. Okay, again, you could think of this as x times x times x 5 times on the numerator, and you can think of x cubed as x times x times x in the denominator. And if we cancel out x's, right, we cancel out these 2 x's and this pair of x's and this pair of x's, we're going to be left with just 2x's in the numerator, or x times x, which is x squared. But the division property says if we have the same base, we can just simply subtract the exponents. So I could have said x to the 5th divided by x cubed is the same as saying x to the 5 minus 3, which is x squared. Right? The division property says same base, we can subtract the exponents. So let's try a few practice problems. So we'll take a look at problems 11 through 20. And just looking at problem 12, I realized there's one more property I think I should mention. On the previous page, there's property 3 called the zero exponent. Basically, any base raised to 0 is always 1. So long as a is not 0 itself, right? We can't have 0 raised to the 0. So any number other than 0 raised to 0 is always going to be equal to 1. Okay? So now back to problem 12. So again, y cubed divided by y cubed can be thought as y times y times y divided by y times y times y. So you notice that all of the y's cancel, leaving me with just 1. Again, we could use the zero property and the division property to rewrite our expression another way. Right, the division property says same base, different exponents, or even the same exponent. We can subtract the exponents. So we're going to say 3 minus 3 is 0, and we know anything raised to the 0 is 1. Let's take a look at problem 14. So again, I'm going to use the division property, and I'm going to subtract my exponents, 9 minus 6, to get 3. And 4 raised to the 3rd is 64. Just want to verify that with my calculator. Yep, 4 cubed is indeed 64. Let's take a look at number 16. So in number 16, I'm going to really just kind of separate my variables. I'm going to look at the x's together and then the y's together. So the x's, I have x to the 2nd over x to the 1st. Remember, if there's no number in the exponent position, then we assume it's a 1. So that's going to be the 2 minus 1. And then I have y cubed divided by y squared. So I subtract the 3 and the 2, and I'm left with y to the 1. Right? So I have x to the 1, and I'm left with y to the 1. So you can really leave it as x to the 1 times y to the 1, or you can just simply call this xy. Let's try number 18. So I can rewrite number 18. I can divide the 12 by 3 to get 4. And then I have x to the 2nd divided by x to the 2nd, or x to the 2 minus 2, times y to the 5th over y squared, which is y to the 5 minus 2. And then we can clean this up a bit further. So the 2 minus 2 is 0. The 5 minus 2 is 3. We know anything raised to the 0 is 1, so we're left with 4 times 1 times y cubed, or just 4y cubed. And then problem number 20 looks like this. So you can see we're left with a to the 2 minus 1 times b to the 3 minus 1 times c to the 6 minus 1. And remember, if there's no exponent above the a, the b, or the c, we assume it's a 1. And then we clean this up a bit. And our final answer will be a b squared times c to the 5th.